Is your doctor killing you? If you have a bacterial infection, they might be. Now, I'm not saying that doctors are evil or bad at their jobs, but there is a fundamental flaw in how antibiotic dosing is determined. So, typically, a doctor will take a sample of bacteria from your body and grow it in a nutrient-rich laboratory broth, which to bacteria is yummy, delicious food. And then we add increasing concentrations of drug until we find the dose that kills the bacteria. Makes total logical sense, right? So what's wrong with this? Well, if we consider that that rich lab broth is sort of like the Caesar's Palace all-you-can-eat buffet of bacteria food. And if you've ever been to an all-you-can-eat buffet, you know that afterwards you were lazy and sluggish, and someone could come and slap you across the face, and you just go, what? But let's consider the host environment. Your body is like a war zone to bacteria. Your immune system is trying to take them out, and they're scavenging for food. So the bacteria in your body are hard. They are tough, like Mr. T. So we hypothesized that a dose of antibiotic that could kill those Mr. Lazies from the all-you-can-eat buffet may not have as much of an effect on those tough bacteria living in your body. To test this, we grew bacteria in the rich laboratory broth that is used for standard antibiotic testing, and we grew them in a broth that mimics the host environment. And what we found was bacteria grown in the host mimicking broth became significantly more resistant to many clinically prescribed antibiotics compared to those grown in the rich lab broth. But how does this relate to actual treatment outcomes? To answer this question, we found 2 strains of bacteria that when grown in the rich lab broth used for standard antibiotic testing had the same level of antibiotic resistance. So to a doctor, these strains would warrant the same antibiotic treatment dosage. However, when grown in the host mimicking broth, our purple strain over here became significantly more resistant to antibiotic, whereas our green strain did not. So we predicted that in an actual infection, the green strain would be susceptible to the treatment dose predicted by standard testing, whereas the purple strain would not. We then infected mice with the green and purple strains and treated with our antibiotic dosage determined by standard testing. And what we found was that the green strain was cleared. The mouse survived the infection because the antibiotic dose was effective. However, the mouse infected with the purple strain succumbed to the infection because the purple strain became resistant to our antibiotic dose during the infection. Hopefully I've highlighted the urgent need for improved testing protocols that take into account the host's effect on bacterial antibiotic resistance, because what you don't know can kill you. Thank you.